Unit 7, Lesson 1, Zeros of Polynomials. So today we're going to look for identifying zeros of polynomials from the graph. And I know you're like, what's a polynomial, miss? What is it? Well, a polynomial is any equation to a whole degree. What's a degree? Well, we've already worked with some polynomials in the past. We just didn't call them polynomials because there are specific polynomials that have specific names, such as y equals 2x minus 1. This is a linear equation. It's a polynomial. It's a polynomial because the degree here, or the highest exponent, is 1. Even though that's not listed here, it is still there as a 1. So this is a first degree polynomial, aka linear function. Then we've also dealt with second degree polynomials, right? We've dealt with y equals x squared minus 2x plus 3. This is also a polynomial, but we know it as a quadratic. This polynomial is a degree of 2 because the highest degree is a 2 right here. Another one we've seen is a third degree polynomial, or a cubic function, right? That's the one that makes a little graph like this. This is a third degree polynomial. I know it's a third degree polynomial because the highest exponent is 3. So a polynomial is anything with a whole degree exponent. The degree has to be whole. What is not a polynomial? Well, a square root function is not a polynomial because a square root function, this degree is actually 1/2. That's not a whole degree, so therefore it's not. Another example is a rational function where I have y equals 1 over x, where x is in the denominator, because this is actually a negative degree. I could rewrite this as y equals x to the negative 1. So those are not a polynomial and not a polynomial. However, linear, quadratic, and cubic are polynomials, but they also get higher. There's also like fourth degree polynomials and fifth degree polynomials. You could create a graph of y equals x to the fourth. You could create a graph of y equals x to the fifth, and so forth. So basically, that's what a polynomial is. And today we're just looking about zeros and we're just identifying them in the graph. So here's a couple graphs of polynomials. This is an odd degree polynomial. This is an even degree polynomial. Odd degree polynomials have their ends going opposite directions. Even have the same way. But if we're just identifying zeros today, all we want to do is look at, we have one here, I think it's about here, and then one more here. So this one has 3 zeros, right? So at -4, -1, and +4. You can also write those in point form by adding that 0 because we go nowhere up or down on the y. So there you go. I have 3 zeros here. However, this one over here has 4 zeros at -4, -1.5, negative or +1.5, and I think this is 3.5. So this one has 4 zeros. This is an even degree polynomial of 4 zeros, which I could say they are at -4, comma 0, -1.5, comma 0, +1.5, comma 0, and 3.5, comma 0. So that's all we're looking for. We're just looking for the zeros. Zeros is another way to say x-intercept. X-intercepts are also called, so they're called x-intercepts, right? We sometimes call them zeros. We sometimes call them solutions. And we sometimes call them roots. Though all 4 of those names are what x-intercepts are, you're going to see them all 4 ways.